So today we're going to start polars. A couple of changes that we've made after our meeting yesterday. First change is your test will now be on Wednesday, May 8th, not Tuesday, May 7th. Okay? Right? So we made that change. Second change that we made is this week, Thursday, is going to be your EMPT test. So this week, Thursday, you need to bring a charged Chromebook with you to class. So you need to have a computer. Yep. Right? Right? So this week, Thursday, charged device, not phone, charged device, ready to go for EMPT. Okay? Test next week, Wednesday, week from tomorrow, instead of a week from today. Okay? All right? Love it. So, with that being said, and those two out of the way, what I would like you to do now is I would like you to solve this equation. X to the fourth power equals negative 16i. X to the fourth power equals negative 16i. So first off, we got to transfer this into trig form because it makes things easier for us. So that's going to be 16 cosine I sine of 270 degrees. Do we all agree with that for negative 16i? Okay. So then we have to take the fourth root of that one. So here now, x then is going to equal 16 cosine I sine of 270 degrees to the 1/4 power, because I'm going to need to take the fourth root here and there. Which means, according to de Moivre, that tells me then that x is going to equal 16 to the 1/4 power cosine I sine of 1/4 times 270. Okay? And that's going to give me my first answer. 16 to the 1/4 power is 2. $270 divided by 4 is 62.5. 67? 637. Yep, 67.5. Yep. Mm-hmm. How many total answers do I need for this one? I need 4. So that means then I have to take 360 degrees and divide it by 4. That gives me 90. So there's a gap of 90 degrees in all of these. What's up? So negative 16i, if I'm looking at a complex number on the complex plane, is straight down. 16 units. So the distance is away from the origin is 16, so that my R value is 16. My theta value, since it's straight down, is 207. So, our last brand spanking new trig topic, and that's going to be polars. Okay. So, up to this point in time, you have been living in the Cartesian coordinate system. The Cartesian coordinate system is like Batman and Robin. Okay? So here is a point out in the middle of Gotham. Okay? Out in the middle of Gotham. Okay? Batman and Robin leave the Batcave, and they have to drive down the city streets a certain distance. Then they have to make a turn, and they've got to drive down some more streets, and that gets you to a point, or the point of where the Joker is committing all of the crimes of X, comma, Y. Okay? You've been doing that for years and years and years. Okay? And it works. You can get to that point that way. Okay? Today, we're going to start talking about polar coordinates. And polar coordinates are like Superman. Okay? Superman starts at the Fortress of Solitude. Okay? And then Superman hears that Lex Luthor is committing a crime somewhere. And what does Superman do? He points in the direction of where the crime is, and he just flies there. Right? He just goes there. So Superman travels a distance. Let's call that distance R. Superman has an angle that he's pointed at. Let's call that theta. And we'll call this down here the polar, not the polar express. We'll call it the polar axis. Why is that so teeny, tiny? The nice thing for us is that this angle theta is going to be a math or a trig angle. So 0 is going to be out to the right. Counterclockwise is going to be positive. Clockwise is going to be negative. And unit circle angles, if you will. Okay? So, how we plot points in polar coordinates. Like, for instance, if we go back to Cartesian, if I go back to X and Y, if I wanted to plot the point 3, comma, negative 2, I would go right 3, and then down 2. And right there would be the point 3, comma, negative 2. Okay. Well, on polars now, if I want to plot the point 2 comma pi over 4 or 2 comma 45 degrees, these are both the same point. One's just written in radians, one's just written in degrees. Okay. This 2 is going to be, or I should say, that polar points are in the form r comma theta. So this is telling me that my distance is 2 away from the pole at an angle of 45 degrees. So I have to find 45 degrees. 1, 2, 3, 4, 5, 6. So these are in 15s. So this is 45 degrees right here. And then I would go out 2 radii. So this is the point 2 comma pi over 4 or 2 comma 45 degrees. And it would just be that point. So if I want to graph the point 3 comma 5 pi over 6, okay, that means I would first need to find 5 pi over 6. 5 pi over 6 is the same as 150 degrees, which would be this one right here. Agreed? And then I would go out how many rings? 3 rings. Yep. 1, 2, and 3. So there is the point 3 comma 5 pi over 6. What about negative 3 comma 5 pi over 6? So on this one, again, I find my 5 pi over 6 ray. But now instead of going positive 3, I'm going to go back through the pole and I'm going to go negative 3. 1, 2, and 3 right there. If I were to connect these 2 rays through the pole, they would be on the same line. Okay? So this is the point negative 3 comma 5 pi over 6. Which means that there are multiple ways to name the exact same point. Okay? Because this point here was negative 3 comma 5 pi over 6. But it could also be positive 3, 11 pi over 6. Because if I go to 11 pi over 6, I'm right here. And if I go out 3, I'm right there. It could also be oh yeah, then the negatives too. I forgot the negatives. Or it could be 3 comma negative pi over 6. Or it could be negative 3 comma negative 7 pi over 6. If I negative here a little bit better. Okay. So my first angle of 5 pi over 6 was there. That was my first angle. Then we went negative 3 back through the pole on. My second angle, my green angle, sorry, reset. Here's my blue angle. My green angle went all the way around to there. My purple angle went negative there, and my red angle went negative to there. Okay. So multiple ways. All of these points, all 4 of those points, get me to that exact same dot. For all 4 of these coordinates, I should say, get me to that exact same dot. Okay? So what I would like you to do now is I would like you to plot this point first, then name it in the other 3 ways. Do we agree that that ray, this, I'll put it in, that ray right there is negative pi over 3. Yep. They're by 15s, so I need to go 4 in the negative direction. 1, 2, 3, 4. So there's that. We need to be out 6. 1, 2, 3, 4, 5, 6 would be out 1 more ring right there. Yes? Yeah? So that is where that point is. Other ways to name that. Well, another way to name that would be 6, 5 pi over 3. If you didn't notice, you should always, your 4 points, or your 4 different ways, one should be a positive positive, one should be a positive negative, one should be a negative negative, oops, and one should be a negative positive. Okay? So we've got positive negative, we've got positive positive. So now we got to go negative negative. So that means I need to get onto, get onto this ray, right there. Yeah. So that would be negative 6, negative 4 pi over 3. Negative 6, 2 pi over 3. Questions, comments, concerns, clarification? Okay. Do you agree that I have to get onto, I'll mark it up, that I need to get onto that one right there? Okay. Right. So that means I start here. This is always going to be my 0. Right. So that means I need to go back. Right. So if I go back, pick purple. Okay. So here's negative 1 pi over 3. negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3. Okay. All right. Try the other two. Plot them. Give me the other 3, 4 of them. So this is 210 degrees down here. I need to go negative 2. So that would be right there. The 30 degree, yep, 30 degree gap right there is negative 2, 210 degrees. My other 3 would be 2, 30 degrees. 2, negative 330 degrees. And negative 2, negative 150 degrees. Yes, ma'am. Because these are in 15. We won't always be necessarily on the unit circle. Like we could, like I could make it, right now we're just doing it on the unit circle to make it nice and easy for you. But later on, we're going to say 100. Okay. Okay. 3 comma pi over 6. Let's see right there. That's positive, positive. Positive, negative would be 3 comma negative 11 pi over 6. Negative would be, so that's negative 5 pi over 6. Negative positive would be 7 pi over 6. Agree? What's up?
Like,
they are not in the same quadrant. Okay. There, yep, it's right there. Because we're renaming the same point 4 different ways. It's just 4 different ways of getting there. Okay? So 3, you got it how we got the first one, right? Went out to pi over 6, went out 3 rings. Okay? Next one. Now instead of going positive pi over 6, I went negative 11 pi over 6 as my angle. Still went out 3. With me? Okay? Next one. I went negative 5 pi over 6. Went to here. But now instead of going this way, I'm going negative 3 back, which means I'm going through the pole and I'm going in the opposite direction. Okay? Alright? And then the last one was we went 7 pi over 6 and then went negative through the pole. Okay? It's not 4 different points. It's the same point labeled 4 different ways. Which is where it differs from Cartesian coordinates too. In Cartesian coordinates, it's always the same point. X and Y never change. Because that would change where the point is. Here, because we've got angles involved, we got positive and negative angles. Okay? So, if I want to change back and forth between polar and coordinate, or excuse me, polar and rectangular is the true definition. Okay? So if I've got a point up here, we'll call it x comma y, and I put, let's see how good I got at doing it. Oh, I was just off. I'll have to move my point. Okay. So if I can put my regular point on a polar grid, but what I need to know from that is I need to know this distance, because this distance here is my R value. Well, how am I going to find that R value?
Oh, x squared plus y squared. Yeah,
Square root of that? Yep, square root of that. Yep. So R here is going to be the square root of x squared plus y squared. I also need to find this angle. Inverse tangent.
Inverse tangent of y over x.
But
That's the reference.
that's the reference angle. Yep, my reference angle is the inverse tangent of y over x. And what do I do with y over x before I calculate it? Both positive drop to negatives. Yep. And then I got to adjust which quadrant it's in, right? Okay, so that is how you go rectangular into polar. Going the other way, going from polar into rectangular, we need the point x comma y is the same. Oops, excuse me. I should go this the other way. Tap the brakes. The polar point would be of the form r cosine of theta, comma r sine of theta, would give me my coordinates. So x is r cosine of theta. We've seen that before. Y is r sine of theta. We've seen that. Okay. So we're flip-flopping back and forth in between. So we want to change the point into the other form. Now, first off, things to look for to determine, well, is this a polar point or is this a rectangular point? Okay? First off, degree symbol on the second number. Okay? If you see a degree symbol there, it's in polar. Okay? Second, if you see pi, it's in polar. Okay? Okay? If you don't see either one of those, then it's in rectangular. Or it will say, change this polar point to rectangular. Change this rectangular point into polar, etc., etc., etc. Okay? So is this point right here in rectangular or polar? That's polar because we see pi. Okay? So we need it to go into rectangular. So my form is then going to be x comma y is going to be r cosine of theta r sine of theta. So that's going to be 3 cosine of pi over 2, 3 sine of pi over 2. Cosine at pi over 2 is 0 times 3 is, nope, 0, yep, okay. Sine at pi over 2 is, times 3 is 3. So this is the rectangular point 0, comma 3. Which makes sense on a polar graph. Pi over 2 is straight up 3 rings. So I'm 3 units up. Okay? Which means I'm at 0, comma. Say B for you. It's gotta be there we go. Let's do C. Okay. Rectangular or polar? Rectangular, because there's no degree symbol, there's no pi, and it just looks like a point. Okay? So I need to find my R value. Square root of 3 squared is 3, 1 squared is 1, 3 plus 1 is 4, the square root of 4 is 2. So my R value is 2. Inverse, yes ma'am. Here we're gonna find the positive positives. Okay? No. Unless it said change it over, then find the other. Like that could be a test question. You know, like we could say here, change it into polar, then find me the other 3 forms. Okay? But then we would first have to find that positive.
This looks like the square root of 4.
Yep. Well, we're going principal root here because we're not solving. It's not. We didn't say x squared equals 4. You know what I mean? Okay. We got an angle yet for this one? 30. Which quadrant are we in? First quadrant, which means we're in the first quadrant in the polar. So this one then would be 2, comma 30 degrees. Would be the polar point. Or 2, comma negative 330 degrees. Or negative 2, comma 150 degrees. Or negative 2, comma, no, correct, yes. Or negative 2, comma 200. Okay? Alright? You find me B and D and E and F. B, D, E, F. Go for it. So, agree with B? 3 square roots of 2, or excuse me, 3 square roots of 3 over 2 and 3 over 2. Okay?
That's crazy.
D, 2 square roots of 2 comma 315 degrees. Yes?
I wrote in radius.
That's fine. 7 pi over 4. Good? Okay. E, three, 239.04. Yes? Yeah? Yeah. So then that is, oops, I should have rounded square root of 34. 5.83. If you would have left it as a square root of 34, I would have been okay with that too. Okay? Good? Love it.